Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zunur bin Muhammad Anwar. Today, I will introduce our project titled Integration of Renewable Energy in Smart Grid. As the world shifts away from the fossil fuels, the demand for cleaner and more efficient energy system increase. Traditional power grid are centralized, rigid, and only support one-way power flow, which limit flexibility and real-time control. In contrast, smart grid allow two-way power flow, digital communication, and better monitoring. They are designed to work with renewable energy source like solar photovoltaic system or PV. However, integrating renewable brings new challenge. Solar energy is intermittent and is produce lower fault current, which can affect the performance of protection system. In our project, simulate a 2.19 megawatt solar PV system within a smart grid using MATLAB or Simulink to study how it affects voltage stability, waveform quality, and protection coordination.
Assalamualaikum, and my name is Muhammad AFIF bin Ibrahim. My metric number is 2110909 and 20. So, I would like to explain about problem statement in the renewable energy. Firstly is challenges of integrating renewable into power system. Traditional protection systems are designed for centralized one-way power flow. Renewable source like solar PV produce low fault current and making detection harder. Inverter replace generator, reducing the effectiveness of all protection method. Second, power quality and stability issue. Harmonic and voltage instability from inverter can cause waveform distortion and voltage flicker. This disturbance may lead to fault tripping or damage to protection device and grid equipment. And the third is lack of inertia and grid reliability risk. Renewable do not provide neutral inertia like synchronous generator. This causes slower system respond to fault, poor fault detection, and potential insulation grid section during fault. So the fourth is propose smart grid simulation and solution. Simulation in MATLAB, simulating which the solar PV farm to test fault scenario. So the point is evaluate modern protection strategies, adaptive relay, RLC filter, booster circuit, PWM based inverter, aim improve protection coordination and system resilience. That's for all for me. So next is Muhammad Nur Fakri.
Assalamualaikum dan salam sejahtera. Today I would like to present about my group assignment PBL disease methodology. First thing first, we will start from flowchart. Okay, from flowchart we will start to input the PV parameter, calculate PV output power, add booster circuit, convert DC to AC using inverter, filter AC output using RLC filter, measure output voltage, current and power, design grid network topology, design utility unit, integrate PV output into grid via circuit breaker, and run simulation in MATLAB. Okay, for the simulating model of grid network topology, it will conduct about 3 generators connected into the generator breaker through the transformer and to the transmission line and to the transformer and distribution breaker, and will connect it to the industrial load measure and through the 3-phase industrial load. Okay, for detailed simulating model of RER integrated in the grid, RER mean renewable energy resources. Okay, firstly, it will from the PV farm. connected to the inverter, into the filter, into the PV measure, and lastly for PV breaker. And the circuit will connected to the Simulink model of grid network topology.
Hello, Assalamualaikum and salam sejahtera. My name is Muhammad Shraizat bin Muhammad Hassan and my matric number is 211090947. And I will talk about result. We have three results. The first one is result for generator output voltage waveform before integration and after integration. In this figure display the sinusoidal voltage waveform of generator A rated at 6600 voltage of renewable energy resource into smart grid. The waveform remains unchanged, indicating that the integration process has not disturbed generator performance. The voltage remains stable at approximately 0.6 times 10 power of 4 voltage, verifying the system stability and compatibility with renewable inputs. Next, result industrial load output voltage waveform before integration and after integration. The industrial load rated at 1100 voltage and the sinusoidal waveform remains consistent and unaffected by integration. The output voltage maintained a stable level of 1100 volt, confirming the successful synchronization of the RER with the industrial load. Lastly, result domestic load output voltage waveform before integration and after integration. For domestic load output voltage, we set rated at 440 volt. The waveform display no noticeable deviation, demonstrating that the integration did not affect residential power quality. The measured voltage remains stable at 440 volt, ensuring that domestic power reliability is preserved even after incorporating renewable source. That's all from me. Thank you.
Okay, now for the conclusion, we observed that the integration of the 2.19 megawatt solar PV system into the smart grid was successful, maintaining stable voltage output across all levels. 6600 volt for generator A, 1100 volt for industrial load, and 440 volt for residential load. This stability was achieved through the use of booster circuit, RLCs, filter, and PWM based inverter, which help reduce harmonic smooth output voltage waveform and improves overall power quality. However, the integration of renewable energy also introduced new protection challenge. Since solar PV system produce low fault current and are connected through inverter, it's become harder to detect and isolate fault quickly. Issues like voltage flicker, harmonic distortion, and reduced system inertia highlight the needs for more adaptive protection mechanisms such as real-time monitoring, intelligent relays, and smart coordination strategies. Overall, we can conclude that while RERs bring environmental and economic advantage, they cannot fully replace traditional generator. Instead, they should be used in hybrid system where both renewable and conventional energy source work together to maintain grid reliability and safety. This project has provided valuable insights into modern power system protection, and it supports future development of resilient, stable, and green energy system.